Hi, I'm Ken Barclay from Barclay Mechanical in Manti, Utah. We've had a lot of questions about what is CNC plasma cutting. And so today we want to show you the basics of CNC plasma cutting. Alright, here we have an oxy-acetylene torch. This has been what you traditionally cut metal with for the last 100 years. It uses acetylene as the fuel, oxygen in order to make that flame hot, and obviously we have a striker to light it up. So here we go. What we're going to show is how a traditional oxy-acetylene torch works really fast. We're going to turn on the fuel, which is acetylene, light it up. As you can see, the acetylene is burning very dirty without any oxygen. We're going to add oxygen to that acetylene and it cleans right up. Plus it makes a hotter flame. The brighter that is, going from yellow to blue to white, is the hotter the flame. What we're looking for is to heat this metal up to create a flame that's hot enough to heat the metal up and melt the metal, and that's how an oxy-acetylene torch works. So we're going to turn it up a little here. Set our torch. Come over to the plate. You can come zoom in if you'd like. And what we're going to do is heat the metal up. Now you can see where I was heating. You can see that heated spot. We're going to get to an orange color. Hit the oxygen. And that's supposed to fall out. Pretty basically, we can create a hole. Sorry everybody, I didn't practice this or set it up or get anything ready. I just used the torch that was available. But that's how we would traditionally cut metal with an oxy-acetylene torch. Alright, this is a plasma cutter or a plasma torch. It is similar to the oxy-acetylene torch is that it's a hand-operated torch that can cut through metals. You know, you typically carbon steel and stainless steel, but the technology is different. It was invented about 1950, but really began use in smaller shops like ours in about the 1990s. What happens here is that you're using electricity to plasmasize the air that's coming out of the oxygen, that's coming out of the tip, and that plasmasized air is at such a hot temperature it melts the steel. So this is what we used instead of an oxy-acetylene torch, for the last 10 or 15 years. The benefits are that it's quick. We can just plug it in, set an amperage, and start cutting our steel. The downside is that we really can't cut with these portable machines much thicker than about 1/2 inch. The oxy-acetylene, on the other hand, we're capable of cutting, up to about 2 inches thick by hand. You want to get any thicker than that, you would have to use an NC machine, which we're going to talk about, in order to hold that torch steady so that you don't wander or wobble too much. This is our CNC plasma cutting machine. What we have here is an NC machine, means numerical control. Basically a computer is controlling where it goes, and we have two different plasma cutting tips. We have a traditional plasma cutter that can go to 85 amps, and we have a high definition plasma cutter that can go to 260 amps. With this tip, we have been able to successfully cut up to 2 inches thick here at our shop. And with the smaller tip, we can go, even with the big tip, we can go all the way down to about 18 gauge or 20 gauge. And with this smaller 85 amp and the roller, we can do sheet metal down to about 24 gauge. So very small ducting is what that's used for. So if you're wanting to run air ducting throughout a building, this is what we would use this plasma for. So the way numerical control works is we have an X and a Y position. Transverse here would be our X, and Y would be the rel. And we have to tell the machine where 0 is when we start up. So we first start the machine, we're going to drive it over to the front left corner and home our axes and tell it to home all axes. If you notice, it's driving itself over till it hits its own limit switches, which tells it that's the 0 in the X, that's the 0 in the Y, and that's the 0 in the Z, which is our torque type.
Oh.
And then it moves itself off of that. So now it put itself, you know, at a height of 0.3 inches and 2.2 in the X and the Y. Now the machine knows where it's at. All right, today to demonstrate the CNC machine, we decided to make some picking eyes. A picking eye is a piece of steel that we can weld to something that we're getting rid of, like when we're out in the field and we're demolishing equipment, we need a place to rig our lifting slings and lift it. So we'll use a picking eye. We can weld it to the structure, hook our crane to that, and lift that out of there. We're going to make some of those today. So come on over to the machine. Now we can make anything that you can draw in AutoCAD, or we can even take pictures and convert it to a CAD file like this abandon all cares picture. It looks like a cabin on the lake. There you go, beautiful.
I love it.
But in this case, we're trying to do something simple and quick. We have a whole bunch of parts that are built into our machine that we can just make on the fly. So I'm going to go here to my picking eye and select it. Zoom in as wherever you want, Kayla. I can build my picking eye here. Right now it's 3 1/8 inches wide, 2.5 tall, with an 1.5 inch diameter circle in the middle. And that's going to be just fine for what we're building. Oh, it's a 1 inch diameter circle, sorry. And it's keeping about 7/8 of an inch of metal all the way around it. That'll work just fine for what I'm wanting. Now I have loaded that part into the machine, but hey, I want to do multiples. So we're going to go tell it that we want to repeat it. And we want 2 of them, you know, 2 rows and 2 hot columns, so I can make 4 parts at one time. That'll work perfect. We'll hit OK. The other thing is, Mark, I need a piece of 3/4 inch plate to make these picking eyes. Can you bring that over? All right, thanks, Mark. Set the plate on the table. How wide is that, Mark? What's long and skinny?
7 inches wide and 43 inches long.
Now if you notice, Mark didn't put the plate on the table straight. That's okay, we have a computer. We can tell it the plate is on an angle, and it will adjust itself to cut these parts on that angle. 7 inches by 30 what?
By 43.
By 43. So we'll come back to our parts. I need 6.82 inches to cut them this way, but I only need 5 9/16 this direction. So I'm going to go ahead and rotate them so that I can get my skinny side on the plate. So we're just going to tell it, hey, rotate, if my finger works, 90 degrees. And it just that quickly, now I'm cutting the parts this way instead of that way. And I like it, it's gonna fit on my plate just fine. We'll say okay. Now we can cut, we're going to be cutting with the larger 260 amp plasma. So we are going to set it up for 260 amps, cutting 3/4 inch thick. It uses oxygen and air in order to do that. Now we have what's called a water table. There's a lot of smoke that is generated when you're plasma cutting. If we shoot that plasma into the water, it will trap the majority of the smoke. That's called a water table. There are other tables that are a downforce table with a dust collection system. We don't have a dust collection system, so that's why we went with the water table. So we've told the machine what we're cutting. The machine already knows from testing from Hypertherm that we want to cut about 90 inches per minute for an optimal cut. This is where plasma is such a great machine. It is not as high a definition as, say, a water jet system, but it is so much faster. 3/4 inch plate on a water jet, you're probably going to be down in the neighborhood of 1 to 2 inches per minute. We're cutting at 90 inches per minute. So it's just going to, you know, that's what, it's 100 times faster than a water table, but it's not near as accurate. It depends what you're using your parts for. All right, we'll tell it okay. Now the machine is got the settings that it needs to run. Now we need to tell it where is that piece of plate. Remember that this is an XY coordinate system. My head is currently sitting at 14 inches in the X and 48 inches in the Y, but my plate's clear over here. Mark, go ahead and scoot that in just a little bit more. It's a little close to my edge. All right, now we have our plate loaded on the table. We're going to go into our current part options and align. That way we can align our part that we want to cut to the plate that we put on the table. And then I'm going to use this align wizard. Lets me walk right through it. Okay, first off I tell it what torch I'm using because I have my two different torches. User defined is my other torch. Arc Glide 1 is my HPR 260. We want to tell it that we want to use, instead of the center of the torch to align it, we actually have a laser on there and we want to use that laser. We tell it where on the plate that we want to locate. We're going to use the bottom right corner. And now we're going to drive it over till that laser is shown on the plate. Now right now you'll notice the laser's not on. I need to turn my torch on. This is actually putting power to the torch. The laser is going on at this point. It's purging the lines so that we have good oxygen, the correct oxygen and air ratio right now inside the lines, ready to cut. All right, so now that that's done purging, I'm going to go ahead and drive the machine over and tell it where the corner of that plate is. All right, so I can slow it down when I get there. And I say, okay, there's the corner of my plate. And we tell the machine that I'm at the corner. Now, adjust for skew. That's, if we had set the plate perfectly straight up and down, we could skip this step. But now we need to tell it, yes, my plate is skewed. Now we need to tell it, what other corner do you want to pick? Well, the bottom left is really close. The bottom right is far away. The further we go, the more accurate we'll be. So we're going to go to the top right. Now we're going to drive up there. Now we don't actually have to be on the exact corner of the plate. We just need to be on that edge. It doesn't matter how far away we are, we just want to be on that right edge. So we're going to slow this down a little bit more until it, boom, right there I'm on the right edge of the plate. I'm at my skew point. Now it's also asking how much clearance do I want from the edge of the plate to these parts I'm creating. This is 3/4 inch plate. I need at least 1/4 inch, if not a 1/2 inch of clearance. So we're going to go with that 1/2 inch and tell it to finish. And now the machine knows where these parts that I want to cut are in relation to that plate. And if you notice, the laser has now gone to my starting point of my cut. And if I like that point, which I do, should be a 1/2 inch in from both edges, I'm going to say perfect. And it tells me, hey, your manual offset is active. That's why I know the laser is there and not the torch head. We're going to say, okay, that's perfect. We can start this cut. There will be a spark as this ignites because it needs to blow through that and create a hole. Once the hole is created, then all of the sparks are going down through the bottom. Now again, this is 3/4 inch thick plate. Here we go. We're going to watch how fast it can actually cut. I hit start. It's going to go over to that start position with the torch head, lower itself down. It can sense with the electricity when it finds the plate. All right, our part is done. We're going to turn off the plasma so it's quieter here, and we'll come show you these parts we just created. Now, one thing you'll notice that is neat, that part came right out. There was no slag, as opposed to when I was running the oxy-acetylene torch and shaking and not either going too slow, so the slag just melted on the bottom, or actually going too fast and not cutting through. The plasma machine, with its computer control, cut that nice clean edge where it's not quite perfect there, but when it was going on the straight runs, we get a really nice cut. We've got some clean holes and very, very little slag. We can actually just take that slag, and it's so clean we can just chip that slag right off that fast, and we have a clean part. If you notice, I'm holding this part even after I just got done cutting it, and that is 3/4 inch thick. If we were using an oxy-acetylene torch, this entire piece of steel would be so hot we would need to give it 20 to 30 minutes to cool down. This part right now is so cool, in fact, I can grab it in my hand and it is not burning me. That's a little long there. I can go about that long without burning myself. But it's because we're moving that at the optimum speed to put all of our heat into the cut and not into the part.
So why aren't these straight, the slats?
So these slats are put on an angle, or wavy inside the table on purpose to create more stiffness. We want these slats to be as little or as thin as possible so that they're not interfering with our flame as it's cutting the material. But it still does. If you notice, we've cut through the slat here in multiple places, and they eventually get damaged. We actually have a program where we can stick a sheet on here and just cut all new slats. Or faster for our shop, we have a shear. We can stick them on the shear and shear out new slats. But we put those slats in here on an angle so that they stay nice and rigid as they're standing up on edge. These slats are used to keep our part out of the water and to create the ground needed for the electricity of the plasma cutter. Now, if you notice again, this is a water table, and one of our parts fell through the slats. So now do we have to go fishing? Well, no. This water table has an air bladder underneath, and we actually pump air into the bottom and push the water up to whatever level we want. And when we're done, we can just let that air back out. And if you notice, you'll see the water start dropping. Now, you're going to say, well, air just goes through water. That's correct. There's actually another steel tank about 6 inches down that goes all the way to that edge, and then the end of it goes to the bottom, and then there's just holes in the very end of that steel tank that are at the bottom. Because again, air will rise to the top, so that tank, that bladder happens to get full of air, but it pushes the water out, pushes it out the bottom and up over the top, and it floods this top surface. We'll fish for our other part. It still is fishing a little bit. We have a hook there. Oh, we grabbed our last part that accidentally fell out. Now, as you can see, it's a little bit dirty in there. We do have to clean this table about every 6 months to a year and clean up all the slag that is created from cutting parts on the plasma table. If a person had to cut those picky knives with oxy-acetylene torch, to cut those 4 picky knives, probably would have taken about, I would say, at least an hour, if not an hour and a half, especially by the time you pull them out, grind them, and clean them up. And we were able to do it in a matter of 5 minutes. That is the basics of CNC plasma cutting. This machine can do anything as large as 6 foot by 12 feet and up to, like I said, up to 2 inches thick. If we come in from an edge, we can go to that 2 inches thick. If we have to cut a hole, it really is down to about 1.25 inches. But great machine for what we do. We're not typically working on a high degree of accuracy like parts for machining. We're typically building base plates or industrial type components here at Barclay Mechanical. If you have any questions, feel free to contact us at 435-835-5084 or info@barclaymechanical.com.